Hello, today we'll be covering permutations and combinations. These are the most rudimentary competition maths concepts. Literally any competition math problem set or like any mathematical olympiad you will pretty much ever attend, these two concepts will be here. So what are they? Permutations is when you select object or more than one object from a group in order. For example, if you're selecting from a body of 10 students, let's just draw 10. It's an example of this is when you take, let's say, 10 students and pick a president, let's label it as P, and vice president. Let me change colors for this. You can label it as V. Since these two are different positions, first we can take, since this first option, president, has 10 options, 10 students, you can say there are 10 possibilities multiplied by, since one student is already eliminated, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities, so 10 times 9, which is 90 different configurations of president and vice president between two students. Of course, this doesn't only have to work for two either. It can work for three. There can be a third position called chairman, like president, vice president, chairman. So you can pick the first one, which is 10, multiplied by 9, multiplied by, since the 9 are removed, there's 8 left, so there's 8, and 10 times 9 times 8, that is 720. Different configurations. So the general formula for this is, for the notation, n big P r is, which this is n, this is the total number of objects, like the total number of students, etc. And the r is the amount of slots that are chosen. Like in this case, it's 3. In this case, it's 2. This is equal to n factorial. I'm assuming you guys have already learned what factorial is. Over, in parentheses by the way, n minus r factorial. So let's apply this formula to the same problem. Okay, so for n factorial, there are 10 students, which is this number. So 10 factorial over, let's try out this one. So there are 3 slots. So 10 minus 3 factorial. So this simplifies to 10 factorial over 7 factorial, which we can rewrite as 10 times 9 times 8 times 7 factorial over 7 factorial, which we can cancel these out. So it leaves us with 10 times 9 times 8, which is also equal to 720. So how this formula works is it's like n minus r factorial. So n minus r, you see that 7 cancels out all the terms that are or to the right of the first r numbers, if that makes any sense. Let's try another example. So let's say in recent events, a World Cup press conference that's deciding which balls to use. Ball number 1, ball number 2, ball number 3, ball number 4, and ball number 5. They're deciding which ball to use as 1, the main match ball. So I'm going to use M. And which ball to use as the backup ball in case one of the balls breaks. So pause this video and try to solve the problem. Okay, so I assume you've paused the video and took a shot at it, but if you still couldn't find the answer or you want to check, here's how to do it. So n is 1, 2, 3, 4, 5. 5 factorial over, there are 2 slots, so 5 minus 2 factorial. So 5 factorial over 3 factorial equals 20. So there's 20 possible configurations of which match ball to use and which backup ball to use. So you've already learned permutations. So now let's try to teach you about the cooler, more useful, in my opinion, just generally in competitions, older cousin combinations. So what combinations does is if, let's suppose you have 10 pool balls, well, they don't have to, 10 balls numbered, they have to be distinct, 2, 3, 4, 5, all the way to, let's say, 20. And you want to figure out how many ways you can choose 2 balls. The difference between combinations and permutations is that permutations had 2 different slots to choose balls from. This time, if you choose 1 and 2 and 2 and 1, it's the same idea. So it's the same thing. So we have to account for that. So how would you do it? So you take the amount of balls, which is 20. You apply the permutations to it. You apply the permutations algorithm to it. So 20 factorial, forgot to write the 0, over 18 factorial factorial. But then you realize the 1 and 2 and 2 and 1 are the same. So every combination of balls, you can flip it and it'll be the same combination. So like for each two balls, for each two like combinations, for this case it'll just be one combination. So you can say times 2, because you'll divide it from this total. So 20 factorial over 18 factorial is 19 times 20 divided by 2, 19 times 10, which is equal to 190. If you were to do it with 3 balls, 1, 2, 3, and since any combination of those 3 balls is pretty much equivalent, a nice way of thinking about this is how many ways you can choose 3 balls to put like some in one singular bucket that is not ordered in any way. So how would you do this? So this calls for the combination formula. How would you do this? Since it's a little bit more complicated, and you can't just say 1, 2, 2, 1. That's 2 combinations, so you just divide by 2. So how? You'd use the combination formula. So you would do n, which I've already said for the permutations is the amount of things to choose from. Then instead of a big P, a big C, and then the R, meaning how many slots, equals, just like the permutations, n factorial over n minus r factorial times n factorial, times r factorial, sorry. This is because, let's say, 2 slots, there are 2 factorial ways of arranging it that will still turn out to be the same arrangement. For 3, it would be 6. Let's say 1, 2, 3. There's 1, 2, 3. There's 3, 2, 1. There's 2, 1, 3, etc., etc. In fact, let me just list them out. 1, 2, 3. 1, 3, 2. 2, 1, 3. 2, 3, 1. 3, 2, 1, and 3, 1, 2. This shows that there are 6 possible configurations here, which is equivalent to this R value factorial. And since all these have to be, or technically the same arrangement for combinations, you divide by an additional multiple of R factorial. So how would you solve this problem? So n factorial, 20 factorial, over 20 minus 3, which is 17 factorial, times r factorial, which is 3 factorial. So 20 over 17 factorial, that is 20 times 18 times 19 divided by 3 factorial, which is 6. So we can cancel this, this is 3, and 20 times 3 is 60, times 19 is, you know what, let's just do this the long way. 3 times 20 is 1200, but since it's 19 and not 20, you minus a 60, which is a nice little trick when it's one more. I mean, when it's one less from 0. 60 is 1140, which is our answer. Another example of this is if you wanted to get, let's say you have like a standard deck of cards, my best drawing of a deck. I'll just abbreviate DC. Standard deck of cards, it has 52 cards, and you want it to be dealt like 7 cards to each person. So you're wondering how many possibilities of 7 cards can you distribute to one person? No clue why you would ever wonder that, but here we are. You can also apply the formula. There's 52 cards, so there's 52 cards to choose from. And since each card is distinct, this should work very well. And another notation for combinations is this, and choose R. 52, choose 7, or 52 factorial over 52 minus 7, which is 45 factorial, times 7 factorial. So since you can't really evaluate this by hand, what you can do is you can use a calculator. I know it's crazy, but you could just use a calculator for this. 133,784,560. So this is your answer, and it's quite the diabolically large number. Hope you learned something.